Alrighty then, welcome back. We are going to be finishing the last part of 5.3 notes. It should be quick and easy. You guys are ripping right through the standard deviation, variance, and that kind of thing. I can't believe how fast you guys are working this stuff, so good job on that. We're just going to do a quick review though. Here's example 511 from your notes. Talk radio has 4 telephone lines. If the host isn't able to talk or is talking to another person, the other callers are placed on hold, and when all lines are in use, they get a busy signal. The probability that 0, 1, 2, 3, or 4 people will get through is shown in the distribution. Find the variance and standard deviation for the distribution. One reason they might want to find this kind of thing is to say, hey, do we need to add some more phone lines? And you're going to have to do a combo of Chevyshev's theorem and to find out if you actually have enough phone lines. But this would be a reason that one would want to find the standard deviation and the variance. So just as a quick review, to find the standard deviation and the variance, you first have to find the mean. And the mean just takes the random variable times its corresponding probability. So 0 times 0.18 all the way down here. And I added another couple rows. I just like to organize it that way. If you do that, you're going to get these values. And then to find the mean, you'll just add them up. To find the variance, you're going to have to square the x up here and then multiply by its probability. So 1 squared times this, 2 squared times this. 0 squared times 0.18 is just 0. 1 squared times this guy is 0.34. 2 squared is 4 times that, which gives us 0.92. This would be 3 squared, or 9, times 0.21, gives you 1.89. 4 squared, which is 16, times 0.04 is 0.64. So you've got all these guys, and then I like to just sum them up so that I have it organized. This guy sums up to 1.6. This guy sums up to 3.79. The mean is this guy right there. So the mean is 1.6. The variance takes x squared times p of x, that sum, minus the mean squared. So 3.79 minus 1.6 squared, bada boom, bada bing, you got it, 1.2. So the variance is 1.2, and the standard deviation is square root of 1.2, or approximately 1.1. So that was just a quick hit on the finding the mean, the variance, and the standard deviation. You want to do it in that order because you need the mean to get the variance. You need the variance, just take the square root of it to find the standard deviation. Expected values. This is where things get a little bit interesting. As we mentioned before, the expected value is just the theoretical mean. It's what you can expect, what outcome can be expected. And so expected value or expectation is used in a lot of different areas. Games of chance, insurance, decision theory, and even investment decisions. Is this going to be a good investment or not? And that's what your activity will do. We'll look at some of those problems. Now, let's look at an example of a raffle. So 1,000 tickets are sold at $1 each for a color TV that's valued at $350. What's the expected value of the gain, that's key, if a person purchases 1 ticket? And they have a table set up, and you can set this up yourselves when you do your word problems. So gain of X, you want to say, what's the possible win? If I win, how much will I gain? And your temptation is to say 350, but you had to spend $1 for the ticket. So your actual win would be $349. What would be your loss? If you lose, you're going to lose $1. So probability of winning has to do with this 1,000 tickets being sold. There's only 1 television, 1 prize, so the probability of winning is 1 out of 1,000, which means your probability of losing is 999 out of 1,000. This is when you need to remember probability. In a probability distribution, these two have to add to 1. So if you get stuck with filling in the last box, you can add the others and subtract from 1. But if you know you got 1 winner, that means you got 999 losers. So then the solution, you just plug it into the theoretical mean formula. 349 times 1 over 1,000, negative 1 times 999 over 1,000. You add them up, bada boom, bada bing, negative 65 cents. So that's your expected value. It's not the actual value if you lose, but that's what you can expect to lose if you play $1. I don't know if that makes sense. So it's theory, but you know if you lose, you're going to lose $1. Let's look at this next one. Here's another one with 1,000 tickets being sold. There's 4 prizes, 100, 50, 25, and $10. After each prize, the winning ticket is then returned to the pool of tickets. What is the expected value if a person purchases 2 tickets? The reason they put this in here is so that each time there'd be 1,000 and a person could win more than 1 prize. They are buying 2 tickets. So if we set this up, we know we're looking for the probability of our gain, our expected gain of this. And if we buy 2 tickets sold at $1 each, we've spent $2. So our gain, if we win the $100, would be 100 minus 2, or 98. The gain if we won the $50 would be 50 minus 2, or 48. The gain if we win $25 is 25 minus 2, or 23. And the gain if we win $10 is going to be 10 minus 2, or 8. If we lose it all, it's going to be -2, because we will have lost $2. Probability of winning. They do 4 drawings and they put the tickets back each time. So there's only one $100 prize. So, and you're buying 2 tickets. So you have 2 chances out of the 1,000. And it's going to be the same for each of those. 2 out of 1,000, 2 out of 1,000, 2 out of 1,000. But what is going to be the chance for you to lose your $2? Well, remember that these all have to add to 1. So 2 plus 2 plus 2 plus 2 is 8. So that means this has to be 992 out of 1,000, because it's 1 minus this whole thing. And 1,000 out of 1,000 is 1. So my expected value, once you have the table set up, it's easy peasy. Just multiply those and add them up. You'd end up with negative $1.63. So that can be your expected value. And like I said, this is a theoretical mean. It's not the actual mean. It's just like you're kind of saying what would be the expected value. You'd probably lose. All right. Let's talk about an investment decision. It's kind of related to gambling in some people's minds. It says there's these bonds. Now, bonds are things that people invest in, usually for governments or for building. You know, sometimes people give bonds for building a new building. And if you invest your money, they use it, but then they pay you so much % on that money. That makes it worth your while. So they have a return of 4% and a default rate of 2%. Default rate, that means that they lose everything and you lose your money. So there's a 2% chance you could lose your money. Bond Y has a 2.5% return and a default rate of 1%. And if you look, the default rate is half that of this. But the return is almost half as well. So you're going to try to say which is the better investment. And to do this, you're going to figure out the expected value. So the return on a bond, if you win, so this is like the win-loss, is 5,000 times 4%, which gives you $200. Now you can set up a table for this as well. I didn't set up a table on the notes, but you can. So if you win, you'll get $200. If you lose, though, you're going to lose $5,000. So the expected return is going to be 98% chance, the probability of you winning, because the default rate is 2%, is going to be 1 minus 0.02, or 0.98. The possibility of you losing $5,000 is going to be 2%, which they gave in the problem. You can see that comes right down there. If you add those up, you get $96. Let's look at bond Y. The return is 5,000 times 2.5. It's $125. That's how much, if you win, you win. If you lose, you know that you've got if it's a 2.5% chance, or if it's a default rate of 1%, that means to win this, you're going to have a chance of 99.99 times 125. Probability of winning is 0.99 times 125. Losing it all is negative 5,000 times 1%, 0.01. When you add those up, you get 73.75. The question is, which one would you choose? That's why you'd kind of do math to help you make decisions like this. So would you choose the one with the $200 return, expected value of 96, or 125, and expected value of 73.75? And sometimes issues in life aren't that clear cut, but you'd obviously pick bond X because the expected return, even if you lose everything, is greater than this guy down here. So bond X is the better investment. Alrighty, and I will see you later.